And wrapping up this first session of Spring Institute 2019 is Dr. Henry Choong, Curator of Invertebrate Zoology. Henry.
Okay, so some of you may notice that is not a hydroid. That is a Vancouver Island marmot. But before I get to the Galapagos, I wanted to start with an example close to home, because the Galapagos story, I mean, it sounds very far and exotic, but it really is our story. Okay, the Vancouver Island marmot is endemic, which means that it is not found anywhere else in the world. Now, because they live in such narrow environments, endemic species are very vulnerable to any changes, and that includes invasions. So, because non-native species, when they move into a new place, they often have left their predators and competitors behind. So when they're in a whole new place, they have no baggage, so to speak, and so they have a lot of unfair advantages over native biota. So non-native species, vulnerable endemic species, bad. Okay, so it's potentially devastating. Now, offshore, it is no different. In the oceans, it's no different, as you've seen from Heidi's talk. But we are often ignorant of the extent to which it's happening. So in 2015, several of my colleagues teamed up with the Darwin Foundation to explore the potential of marine invasions in the Galapagos. I specialize in hydroids, so I was asked to look at the hydroids that they found. What are hydroids? Hydroids are, you're about to get a 30-second lecture on hydroids. This is the most condensed I've ever done hydroids. So hydroids are small, gelatinous animals related to corals and jellyfish. Now what's pertinent to our talk today is that hydroids like to live on many different surfaces. They like to live on different kinds of surfaces. They like to live on each other. They like to live on other animals. They like to live on debris. Okay? They like to live on nets. Now, because they like to live on sides of boats, for example. Now, because of this, hydroids can be transported long distances on floating debris and hulls. So hydroids make very good model organisms to study how marine species may be introduced. Now, on to the Galapagos. The ancestors of animals which colonized the islands frequently found themselves on a one-way trip. Now, the Galapagos environment varies greatly across time and space. And what I mean by that is there is 7,800 square kilometers of island spread across 45,000 square kilometers. Okay, so you have a vast amount of, you have a relatively big space, relatively few islands, about 13 main islands, okay? And what you have are all these different environments within the same island group. So over time, these isolated populations become reproductively and genetically distinct, right? Essentially, what happens is they evolve into different groups, different species, different endemic species. So in the Galapagos, endemic levels for terrestrial animals reach up to 90% and 80% for marine species. Now, by contrast, only 1 to 5% of Canadian species are endemic, right? So our Vancouver Island marmot belongs to a very exclusive club. Now, high levels of endemic species, along with their relatively small numbers on the island, make them very vulnerable to invasives. Right? Nearly 500 years of human contact in the Galapagos has led to numerous introductions of terrestrial animals. or non-indigenous species, or NIS for short. Now we know that we know relatively more about the terrestrial species than we do about the marine species. For example, in our study, we found that between 1991 and 2000, there had only been 5 marine and maritime documented introductions. And as you can see, that includes 2 shoreline flies. So we know, we don't know very much about what happens in a marine system, right? So how do you explain that difference? Well, let's consider then, again, how marine species spread. Okay, we know that they swim, right? Well, they don't. Not in the way that we think. Not when it comes to spreading. So, as Erica mentioned in her introduction, currents and temperature can be just as effective barriers in the ocean as mountain ranges are on land. In fact, so long-distance transport of many marine species is achieved by hitchhiking on ships or debris. And in fact, when Darwin arrived in the Beagle, on the Beagle in the Galapagos in 1835, he probably brought with him quite a few invasive marine species attached to the hull of the Beagle. And you can see, after the Panama Canal opened in 1914, there were even more opportunities for this spread. So because the hitchhikers now had a shortcut from the Atlantic or from the Caribbean. So it begs the question even more. Why so few introductions? Well, let's go back then and consider and look at the environment that they're coming into. Let's consider 2 possibilities. 1, there are more introductions, but they're not detected. 2, species were introduced, but they couldn't find suitable places to settle. And we could test this. We could test this because prior to our study, much of the work on marine systems had focused on natural habitats. But things have changed a lot within the last 100 years. There are many, many more artificial maritime structures, such as docks and pilings today. And we know from previous work that harbors and pilings are known invasion hotspots. So we asked 2 questions then. Most taxonomic groups, unrecognized or undetected, did the absence of artificial habitats constrain colonization? And going back to my model organism, now hydroids are great model organisms to explore this question because they travel by hitchhiking and they love artificial substrates. So we looked at hydroids on docks and pilings, and 2 of the islands, just 2 now, remember this. We examined field collections, identified species, and mapped their distributions past and present. And for these, we looked very much towards museum collections and museum expertise, because where do you find specimens? Where do you find records? And where do you find people who study them? You find them in museums. So we looked for species which did not belong, or species with strange distributions. We looked for species which may have been already introduced elsewhere in the Pacific, okay? Because when you're faced with a pile of organisms, how do you sort them out? So you start thinking about these things. What we found was 10 times the number of introduced species as previously reported in the Galapagos. Over 90% of the species we found in just these 2 spots, off of 2 islands now. 90% had not previously been found anywhere. So what can we conclude from this? We can conclude that A, tracking changes to the environment and recognizing pathways for invasions, they go together. We have to do both. That artificial structures along shorelines are hotspots for potential invasions. And this has critical implications for marine invasion management. And this is pertinent not only to Galapagos, it's pertinent to us too. If you think about the numbers of docks and pilings that we have on the island. And finally, we still have work to do because we're still finding new species, and we know that invasions are imminent. So there's more to come. Thank you.